Hello all, as we continue our look at integration. In this video we're going to have a look at integration of circular functions, and in particular sine and cos. In the Year 12 methods course we don't actually do integration of tan, so just one slight thing we don't have to worry about. Also, because this should be a fairly quick video, I will also try and throw in having a look at doing this on the CAS calculator head, and in particular the Casio ClassPad, because it's a little bit different to the TI Inspire. But basically, if we do remember that the derivative of sine is cos, and the derivative of cos is negative sine, if we work backwards, we can, and I guess effectively, when we work backwards, it's almost sort of like doing inverse operations. We're going to bring this underneath, which instead we can write out the front like it's shown there. Same with this, we can bring it back and bring it underneath. So we get the antiderivative of sine is negative 1 on k cos, and the antiderivative of cos is 1 on k sine, with k being the coefficient of a linear internal function. This doesn't quite work as well if we had a polynomial of higher degree than 1 inside the sine or cos function. There is, if you download the slides, there is this visual demonstration showing this as well. But let's get straight into some examples. So first off, we'll find the antiderivative of each of the following. So we need to find the antiderivative of 1/3 sine of 2x. With regards to x, we're assuming, so we can bring the 1/3 out the front. Sine 2x x is equal to, and if we just go back and check our rule, sine antiderivative is going to be negative 1 on k cos. So we're going to have 1/3, and then we're going to have the negative 1 on, and our k value is 2. So we get 2, and let's put this in brackets because this is not 1/3 minus, these are going to be multiplied, and that's going to be cos 2x. So if we simplify, we get negative 1/6 cos 2x. Okay. Antiderivative of cos of 2x minus pi on 3 is just going to be equal to 1 on, and our k value in this case happens to be 2 again, so we get 1 on 2 sine 2x minus pi on 3. And that's pretty straightforward. Let's have a look at this last one. We can see we've got a plus term in here, so using the, we could simplify this into 2 sine 5x plus antiderivative of 3 cos x on 3. We've been doing this for a while now, splitting this up just so really showing that any terms or not equations, what's the word I'm looking for? It doesn't matter, but pretty much any two functions separated by a subtraction or addition, we can separate the integrations. We can still leave it inside the one single integration sign and just work on them separately. So we're going to get 2 times by 1 on, and for sine we bring the 5 underneath, and when we take the antiderivative of sine, it becomes negative. We get cos of 5x plus 3 by 1 on, and this is interesting. We see that's 1 on 3, so people have that inclination to put the third straight away, but to be clear, this is 3. Let's just put something dividing here. This is 3 cos of 1/3 x. So our k value is technically 1/3, so we're going to put 1 divided by 3 there. And that becomes sine x on 3. And now we just need to simplify. So we get negative 2/5 cos of 5x plus 3 times by 1 on 1/3. Well, let's just focus on the 1 on 1/3 at the moment. That is the same as 1 times by 3 on 1. Just when we divide by a fraction, we end up multiplying by the reciprocal is the same thing, so we just get 3. And that was, to be clear, that was just this bit. Gives us 3, so we end up with 3 times 3. So we get 9 sine x on 3. Cool. So that's just finding the antiderivatives. So let's now take that a step further and actually find a definite integral. We'll just do the one on the left and we'll leave the one on the right as just a bit of a warm-up for class. So this is going to be equal to, when we take the antiderivative of cos, that becomes positive sine of x, and we've got our terminals as pi on 3 and 0. We substitute the top one in, so we're going to get sine of pi on 3, take away sine of 0, and this is where you need to call back on remembering what those are, but if we just think about it, pi on 3 is, so that's pi on 6, pi on 4, pi on 3 is this greater angle, or that we recognize as 60 degrees. Sine is the horizontal component, so being the greater angle, it's the biggest one. So if we just remember that we had 1 on root 2, 2 on root 2. Hold on, I've gone blank myself on this. These are root 3 on 2, root 2 on 2, half. That's right, and we want this one. Root 3 on 2, and then minus sine of 0. Well, 0 would go across, sine's the vertical component of that, which happens to be 0, so we just get root 3 on 2. So the area under a cos graph from 0 to pi on 3, we just think quickly what a cos graph looks like. It's like that. There's pi on 2. So pi on 3 is about there. So we've just found that area there, which turns out to be root 3 on 2. Like I said, we'll leave B for a warm-up, and then there'll also be all the prior exam questions to work through. But let's now look at the Casio class plan. You can see I've already got one loaded in there from something else I was working on. If we bring up the keyboard, let's have a look. There we go. So there's a bunch of different ways we can do this. That's the button there under Math 2. Yeah, it's only in Math 2, so that's the way to do it. To be clear, if you do action, and then we want to do calculation, there's the integral sign there, we can bring it in. That integral sign only works as a indefinite integral, so it's only going to do antiderivative. You can't put terminals if you go through this action menu. Can still use that symbol, especially if you're just doing the antiderivative like we were on these pages here. So let's just have a go at 1/3 sine of 2x, just to check our work. Close bracket, and we got negative cos 2x on 6, which, yeah, we had negative 1/6 cos 2x, same thing. So that works there. What you can also do, though, and this is only, instead of through the action menu, this is through the interactive menu, is if that you put in the function first that you want to find the antiderivative, and this is if we want to find the definite integral. You can go interactive, calculation, click on the same symbol, and just because we've already got a function in there, it's actually now going to give us this. It's going to preload the expression. That's the word I was looking for, not equation before, but expression. And then you can choose if you want to do it as an indefinite integral or a definite integral. And if you do choose definite, like I just did there, change to definite, it's going to let you choose your lower and upper terminal. So lower, let's cancel out of this and just double check our work on the next slide. We had, what was it? We were just finding antiderivative of cos x. Like that, so we highlight it, interactive, calculation, click on that, choose definite. Our lower bound was 0, our higher bound was pi divided by 3, hit OK, and yeah, we got root 3 on 2. So I did it all correctly. Let's have a check on play on this, because I haven't actually technically played around with this one. But what happens if we just take that, put X in, and not put terminals? Is it going to work? Yeah, it'll work. But then if we go back and put terminals in, it should then turn into a definite integral. Pi divided by 3. Hit enter again. Yep, and it's changed it. So I would suggest personally just using this button here in Math 2, but just be clear that action calculations are always going to just be an indefinite. Interactive will give you the option. Yeah, that's it for today. Nice and short, 11 minutes. As always, if you have any questions, stick them below. Shoot me an email, put it on Google Classroom, or hit me up in class. Thanks and see ya.